So last week we learned all about confidence intervals and hypothesis testing for proportions. So far this week in chapter 18 we learned all of that stuff for means as well. So chapter 19 is not just related to means. Chapter 19 is related to all tests and intervals. Let's talk a little bit more about maybe choosing a correct confidence interval, what an error is, etc. So don't just be thinking about means in this case, this is both. So when we create a confidence interval, we're using a critical value that corresponds to the confidence interval. And critical value, I mean, that's my z star for proportions or my t star for whatever degrees of freedom for means. If I want the same level of confidence for my test, which of course I do, because we already talked about how important it is that our confidence interval agrees with our hypothesis test conclusion, we want to make sure that we're using the same level of confidence for the test and the interval. So essentially, and again, this is just reminding you, if we reject the null, the hypothesized value should not be in the interval. If we fail to reject the null, the hypothesized value should be in the interval. So how do we make sure that the level of confidence we use is the same for both? Well, it changes based on the alternative hypothesis. So first of all, we need to understand the difference between a one-tailed test and a two-tailed test. So if we're using a one-tailed test, remember that means my alternative hypothesis is either that mu is greater than something or mu is less than something, or that p is greater than something or that p is less than something, because it's just on one side essentially. The two-sided that we'll do in a little bit is the not equal to. So this is everything except for the not equal to's. So how do I compute, or how do I make sure? You can do it using the formula that says, and there's really two formulas. There's a formula that helps if you already know alpha, and a formula that helps if you already know the confidence interval, and it really doesn't matter which one. I tend to use this one. But essentially what we're saying is, if your alternative is one-sided, what happened is all of alpha went to this side. And so if I want to make sure that my test corresponds to my confidence interval, I need to do the same thing on this side. And so really I have to take two alphas to do that. So my confidence interval is the space in here, which would be the 100% minus 2 alpha, and again alpha typically is 5%, or 1 minus 2 alpha if you're dealing with this as a decimal, 0.05, and this alpha would be if I was writing it as a percent. So we just performed a one-tailed hypothesis test. If we used alpha as 0.05, then again that's 5%. I'm taking 2 times 5 to say, well, that's 10%. 100 minus 10 is 90%. That means the interval here in the middle is 90%. Now, what happens when my alternative is two-sided? Well, that means that mu is not equal to is the alternative hypothesis, or that p is not equal to is the alternative hypothesis, depending on means or proportions. And again, we're already taking into account that because my alternative is two-sided, my test is two-tailed. So I'm already taking this into account, which means everything in the middle is just 1 minus alpha, or 100 minus alpha if you're writing it as a percentage. So again, that's how I'm going to determine that. So if I did a test with an alpha level of 0.05, then that means the interval that corresponds to it is 95%. So I really like this question because the last two that I talked to you about, I gave you the alpha level and you were just solving for what confidence interval should I use. On this question, the actual question says, what level of significance did management use? That means, what's alpha? So in this we're saying a company manufacturing computer chips finds that 8% of all chips are defective, Management is concerned that employee inattention is partially responsible for the high defect rate. In an effort to decrease the percentage of defective chips, management decides to offer incentives to employees who have lower defect rates in their shifts. The incentive program is instituted for 1 month. If successful, the company will continue with the incentive program, and if management found a 95% interval, what level of confidence or what level of significance did the management use? So if you feel up to the challenge, press pause and try this question. Otherwise, we're going to go through it together. So again, our test would be one-tailed. Now, that's important to know that. So how do I know that? Because it says in an effort to decrease the percentage of defective chips. So if I were testing that, then my test would say, did my proportion lower from the 8% that I expected? Because that's where I would start. So I need to do this before I try to do any other math. Was it one-tailed or was it two-tailed? I'm expecting 8%, so this is my null. My alternative is, did their efforts decrease the percentage of defective chips? That's why it's one-tailed. So I'm using an alpha level of 1/2 times 100 minus c. So this was just the other equation that I had for you. And you can use either one. But again, if you use the other equation, then I'm saying let's find alpha. And I would get 1/2 times 100 minus 95, 95 from here. So half of 5% is 2.5%. So again, that was using that second formula. Now, if you're like, hey, you know what? I don't want to use that formula. I liked the one that you used on the last slide. Well, that one just said the level of confidence is equal to 100 minus, and because it was, again, one-tailed, it was 100 minus 2 alpha. So if I wanted to use this instead, I'm going to plug 95 in here for the level of confidence, and then I'm just going to do the work to solve for alpha. 95 minus 100 on each side gives me -5, and that's -2 alpha. Divide each side by -2, and I still get 2.5% for alpha. So either way you do it, you should get the same answer.